Hey guys, today we are going to see sorting elements by Quicksort. Welcome to the problem solving playlist. So today we have a problem, that is we have unsorted array. We need to sort that using Quicksort. So if you want to know more about Quicksort, don't forget to check our data structure and algorithm series Quicksort video. And if you are not familiar, please go and check the video and come back here. In this problem, we have an unsorted array, that is set 10, 7, 8, 9, 1 and 5. So as per our algorithm, we need to take lower index and higher index. The lower index is zeroth index, higher index is the last index. So we should take a pivot element. So pivot element is for this problem I take pivot element is the last element. Okay, so then we need to find pivot index first. So we need to call the partition function. So in the partition function, I and j. So initially, first element should compare with the pivot. If first element is greater than pivot, it should be swapped. Then 5 will be go there and 10 will be go there. Second condition is I should be lesser than j. If these two things is okay, then we can move forward. If I is greater than j, we need to swap these two things. So the first condition is the first element or the current element should be lesser than pivot. If not, swap the third. Second condition is the first element and the second element. First element always lesser than the second element. If not, swap those things. That is the overall idea after sorting. So just we directly jump into the solution. I'm using solving the problem using Python. Also, I'm using Colab. It's a Google open source. You can run your Python coding here. It's just similar like a Jupyter notebook. Okay, we enter here. Our algorithm, we have two things. One is parent function, and another one is to find a partition. So this is the boilerplate code. So I have array, an unsorted array, and I just pass a quick sort function into this array. So this is here is we have a quick sort. I just writing a complete code, so only I'm using extra one function. So when I receive the array here, and I just call the quicksort, it's actual quicksort function. So I just pass the same array and I take a starting index as 0 and the last index will be the length minus 1, which means the last index. So directly jump into the quicksort main function. So in the function, we need to check whether the L always should be lesser than R. If not, just return empty. Just return null. So that's the thing here I wrote. And if this condition is not satisfied, we need to move else point, that is this. And here we need to find partition. So partition is nothing but it's just to find the pivot index. So exactly where we need to split the index. So that is the partition function will give. So I just pass these three things into partition function. So we are moving into partition function. So here I just take last element as pivot value. Then I just run the for loop. The for loop started from the 0th index to last index. So as per our algorithm, we need to check whether that current element it should be lesser than pivot. If not, we need to swap the current element and pivot element. If yes, we need to find whether that I should be lesser than j. If not, we need to swap I and j. So that's the thing. Once it's done, it return I plus 1, which means that is the pivot index. So here we receive the pivot index. So once we receive the pivot index, we need to call the function recursively. So how we need to call the function recursively? It's very easy because we have a pivot index. So pivot index minus 1, which means 0 to pivot index minus 1, that is one range, and another range is pivot index plus the last index. So that is the first function, the pivot index minus 1. The second recursion is pivot index plus 1 until the last index. So these two ways will give us improve the speed of this sorting. So let us assume we have a 12 elements. So from the beginning, it's split into 6 6. After, it's split into 3 3, which means a big problem is split into four parts or n number of smaller parts, and the smaller parts is supposed to be sorting and merging into and merging, and finally it will give sorted a big array. So that is the approach. That's why it's called divide and conquer algorithm. Also, it's called a comparative programming, and it's a dynamic programming thing. These are the thing. It's very, very important for coding. So if you are not aware of these things, don't forget to our previous videos in data structure and algorithm. Back into our presentation. So that is, I hope you are understand how to sort an elements using Quicksort. Don't forget, Quicksort is not a fastest algorithm. If you want to know more about another sorting methods, don't forget to watch our future videos. If you want to join in with us, join in our Facebook group. Thank you guys. Don't forget to join our Facebook group. And if you have any questions, don't forget to comment, like, and share with your friends. Don't forget to subscribe our channel. Thank you. Bye bye.